So voltage regulation at leading power factor. Now we'll drive here. So this is the secondary side of transformer equivalent diagram. Yes, E2 is the induced voltage in secondary winding. R2 is the resistance of secondary winding. X2, JX2 is the reactance of the secondary winding, and load is connected here, and across the load is voltage is V2 and current is flow through the load is I2. So load is capacitive here. So V2 is a reference phase. Reference phase is magnitude is V2 and angle is 0 degree. And I2 will be load current. Now capacitive load, that's why I2 will be lead by voltage, and that's why it is coming as plus phi, and phi is the power factor angle. Now again we will write the equation E2 is equal to V2 plus I2 R2 Z2. So we can write here I2 into Z2. So we also write here E2 will be V2 angle 0 plus I2 will be I2 angle plus phi, and multiply by Z2 is equal to R2 plus JX2. So now we can make to the convert to the Cartesian form. We can write here E2 is equal to V2 plus I2 cos phi plus I2 j sin phi. Into multiply by R2 plus JX2. So after multiplication we can open the bracket. So we will find out E2 is equal to V2 plus I2 R2 cos phi plus J I2 X2 cos phi, then plus J I2 R2 sin phi, and here J and J will become minus, so we can write here minus I2 X2 sin phi. So again we will separate the imaginary terms and real terms. So imaginary terms having low value, that's why we will neglect the imaginary terms, and we will only interested for the real terms, because the value of real terms V2 is very high, so adding of this will be more, so that's why imaginary term will be neglected. Now we will write after neglecting the imaginary term, we can write here real terms V2 plus I2. So after neglecting we can write here E2 is equal to V2 plus I2 R2 cos phi minus I2 R2 sin phi, and also we can write here imaginary terms, but we have to neglect them, but here write the imaginary term will be I2 X2 cos phi plus I2 R2 sin phi. So these terms we neglect because this value is very zero. So we can write here E2 is equal to V2 plus I2 R2 cos phi minus I2 R2 sin phi. So we just shift in the left hand right hand side. So we can write here equation E2 minus V2 and divide by V2. So it will be like this, is equal to I2 R2 cos phi minus I2 So here the value is x2, not r2, x2. Here also x2 value. So I2 x2 sine phi x2 sine phi divided by V2. So voltage regulations at leading power factor will be, voltage regulation formula in leading power factor will be in percentage, we can write here I2 R2 cos phi minus I2 x2 sin phi, I2 can write here I2 R2 cos phi minus I2 x2 sin phi divided by V2. So this is the final expression of the voltage regulation at leading power factor. Thank you.